Welcome to the video lecture series of Fourier transform. In this video actually I will discuss how to determine the Fourier transform of a given signal xt by differentiating n times. So in this example, if you are being asked to determine the Fourier transform of xt like that, here is the signal, this is the triangular signal, and in this process you need to determine the derivative of that. So as we have discussed in the previous video that how we get the result after differentiating a ramp signal, unit step. So here this portion is actually the ramp. So after differentiating we get the unit step like that. So and this portion also a negative a ramp having the negative slope. So as we know that after differentiating the ramp signal we will get the unit step. So this portion actually transformed to that, and this portion is transformed to that. So another thing, we also know that after differentiating the unit step function we will get the impulse function. So if we determine that portion, differentiate that portion, basically if we differentiate whole signal dxt dt, then we will get d square xt dt square. So in that case this portion actually represent the unit step. So after differentiating this part we will get the impulse here, and this slope actually, this portion actually represent after differentiating actually the negative slope here. However, this portion also should be differentiated. So after differentiating this portion another impulse will be achieved here. So at that point two impulse having negative direction. So after summing up the amplitude would be double, as you can see here. So this portion can be represented after differentiating a magnitude with minus 2t divided by t tau, and this portion also can be represented after differentiating is minus 2 divided by tau. So as at the same point two magnitude can be represented by the summation of them. So the overall representation would be minus 4 divided by del t. So in the similar fashion, what would be the magnitude of that, because this was the magnitude 2 divided by tau. So this, in this case, 2 divided by tau, and we know that the impulse actually present at the unit impulse can be presented at this axis point, origin. So but already it has been transformed to t is equal to minus tau divided by 2 minus tau divided by 2. So ultimately this signal can be represented by del t plus tau divided by 2, having the magnitude 2 divided by tau. So I hope you can understand how to differentiate the signal in several times. So now what would be our ultimate goal? So our ultimate goal is to determine the Fourier transform of a signal in the process of differentiation. So we are given a signal, and just after differentiating in 2 times we got the signal like that. Okay, so also this can be determined by writing this signal into functions like that, as we have seen that this is the ramp. So this ramp can be presented having the magnitude 2 divided by tau, and as it is presented in t divided by tau minus t divided by tau. So this fashion can be suited for this ramp. also in that case this is also a ramp, so this is 2 divided by tau r t minus t divided by tau. So what would be why we have to write this? Actually, as I have discussed in previous videos, that a signal can be represented by different singular function. So if we think that this portion all contains with a positive ramp slope and having a negative ramp a ramp in with a negative slope at the origin. So ultimately this portion will be determined, and in similar fashion this is the ramp having the magnitude 2 by tau at this portion, and if we add with a ramp with having negative slope at the origin, then this portion would be achieved. So this portion contains actually a positive a ramp having positive slope and a negative and a ramp having negative slope at origin. This portion will be portion can be made, and this portion can be made by two ramp having a negative slope at origin and a positive slope at t by tau. As as in negative as two ramp having negative slope at the origin, so after summing up this portion can be determined. So actually after I want to mention here, so like similar fashion here this portion have been made after adding up two signals. So in similar fashion, actually after adding up two ramp, this portion have been made actually. So as we know that as you know that if we differentiate the ramp signal, we will get the unity step. So after differentiating that portion, we will get the unity step, and again if you differentiate that portion, you will get the final outcome. So you may go through that way, or you may go through direct differentiation to the signal given to the question or when you are being asked. So so this is the two way, and your ultimate goal is to determine the Fourier transform. So this is the first stage. You need to determine the 2 times derivation of a given signal, and then you need to transform this fashion. So this is the property of Fourier transform. So what would be the law of Fourier transform? If you the law is, if you need to transform any derivative, then you just need to put j omega and placing the degree of differentiation. Here the degree is 2, so you need to put j omega with the degree 2. So the Fourier transform of xt is x omega. So this portion can the Fourier transform of this portion would be j omega square x omega. I think I hope you can understand. So the Fourier transform of del t, actually we know the Fourier transform of del t is e to the power j omega t. However, here t is replaced by t plus tau t. So here is the Fourier transformation. Here del t is 4 divided by tau, because actually the Fourier transform of del t is 1. However, here as the t is replaced by t plus tau divided by 2. So using the Fourier transform, the ultimate Fourier transformation of del t plus tau by 2 is e to the power j omega t tau by 2. I have already discussed in previous video, so you can check that. So in similar fashion, the Fourier transform of that would be like that. However, the Fourier transform of del t is 1, but as using the Fourier transformation of time shifting, this would be the ultimate Fourier transform. So after having the Fourier transform of whole equation, you need to determine actually the x omega. So after dividing by j omega square, you will get this fashion. Actually, this is the sinc function. As I have said earlier that I will discuss about the sinc function. Basically, sinc function actually can be determined by sine theta divided by theta. If you have any portion like sine theta divided by theta, you can replace by the sinc function. So this is the sinc function. So whole part could be replaced by sinc, and this would be the sinc square omega tau divided by 4. I hope it would be very easier for you, but you need to practice in several time. So and what would be the final destination? Our final destination is to determine the Fourier transformation. So we are given the signal xt, and we need to determine the Fourier transform of that. We need to determine the x omega. So in this case, our final result is x omega is given by tau divided by 2 sinc square omega tau divided by 4. So basically, from this video we can conclude that if we are asked to determine the Fourier transform of any triangular signal like that, t divided by tau, here for having the t divided by tau, we need to place minus t by 2, and the distance from that to that would be t tau. So t divided by tau can be replaced, can be presented as the triangular function. So if you need to transform these triangular function into Fourier transform, you need to just write this fashion. You can use this as a Fourier transform properties or Fourier basic Fourier transformation. So I hope this would be very helpful for you, and after practicing in this fashion, in coming videos would be very easier for you. Thanks for watching.